Hi everyone, today I want to talk about translating parabolas. So yesterday we did parabolas that had a vertex at the origin. Today we're going to talk about when that vertex is no longer at the origin. We'll talk about some terminology and how we're going to approach these problems. So let's start out with y squared equals 4px. Remember that if y is squared, that means our parabola is opening either to the left or to the right. So if everything is positive, it's opening to the right. If it's negative, then it's opening to the left. And we said that the focus is located at P0 and your directrix is located at x equals negative P. Okay, so your focus again is kind of inside the concavity of that parabola, where your directrix is on the other side of that, of the vertex. And it's a, in this case, it's a vertical line that is the same distance from the vertex as the focus is. Okay, so let's look at this equation. Let's write it a little bit differently. Instead of writing just y squared, I can rewrite that as y minus 0 squared. And I can rewrite x as x minus 0. Right, that's the same as what we had up here with a vertex then of 0, 0. So if I want to replace the 0, 0 with coordinates of a point, I would write it as y minus k squared is equal to 4p times x minus h. And so now my vertex is at hk. Okay, my vertex is at hk. And now what happens to my focus? My focus is now take h and add p to that, comma k. And your directrix is going to then be at h minus p. So all I'm doing is just adding in that h component to those x values. So let me show you what I mean. If you were to graph that, so let's say you have a parabola that is centered here at hk, and so your parabola goes like this and comes around like this. Not the best drawing. Actually, I guess that would be more, let me redraw that because that didn't come out very good. Okay, sorry guys. So let's say our parabola is like this. Oops. Like that, there we go. So here is here's your center at HK. Your focus is going to be somewhere over here, right? So it's going to be on that same horizontal, if you had an imaginary horizontal line here, your focus would be here, and the coordinates of that would just be h plus p, comma k, right? So this distance from here to here is p, and then the distance from here to here is also p, we just call that negative p, and then here is your directrix, and that would just be at h minus p or h plus negative p. You can kind of think of it that way. Okay, so that's what the graph would look like. Okay, so that's just when you shift it, that's what happens to your coordinates. And if you notice on your note sheet, I just have the two different types of parabolas, and then I have two graphs on the bottom. So if you wanted to just put this on one of the graphs on the bottom of your sheet. Okay, then we'll look at the other kind. So when we have a parabola that opens up or down, if I were to go ahead and replace the x with x minus 0, right? Because I can easily write it like this. It means the same thing, right? And that's still telling me that my vertex is at 0, 0, but now I can replace that with h and k. And so now my vertex, if if you want to think of that. Your vertex here was 0, 0. Your vertex here is at HK. Your focus was at 0P, but now it's going to be at H, comma, K plus P, because now our parabola opens up or down, so we have to move our focus up or down, right? In our directrix, it was at y equals negative P, and now it's going to be at y is equal to K minus P. So again, if we were to draw that, so if this is my parabola, right, there's my HK. If my focus is here, that distance from here to here is P, and so then my distance, P, my distance from here to here then is also P. My directrix would end up being down here. Okay, and so the equation of that line would be y is equal to whatever that K value is minus P. And then your focus, which is here, is whatever that H was, and then you add P to that K value. And we'll do a couple of examples, but that's the idea behind moving that parabola. Okay, so let's do an example. It says to find the vertex, focus, and directrix. So when you look at this equation, first of all, we know it's going to open up or down because x is squared. So I know it's going to open up or down. So our vertex, or our HK, is going to be at 3, negative 1. I know that what's in front here, that's 8, that's my 4P. So 4P is 8, which means that my P value is 2. Okay, so here's my vertex. My focus then, because it opens up or down, I'm adding or subtracting from the y coordinate. So then my 3 stays the same, and then I'm taking negative 1 plus 2. So my focus ends up at 3, comma 1. And my directrix would be y is equal to K minus P. And so my directrix would be at y is equal to negative 1 minus 2, or y is equal to negative 3. So if I were to graph this, right, my vertex is at 3, negative 1. My vertex is here. And because P is 2, and I know that it opens up, I really just have to plot my focus up here, which we found was at 3, negative 1 anyway. And then I know that my directrix is 2 units in the other direction. So I know that my directrix is going to be right here. So the question is, how wide is your parabola? How large is it? Does it open really wide, or is it more narrow? And that all comes basically from here. There's a line segment that goes through your parabola, and now I just can't remember if I said this in the video from yesterday or not. So if I did, you're hearing it again. If not, then this is going to be new. The idea of how wide the parabola is comes from this, 4P. 4P is 8. That means if the whole distance is 8. And what distance am I referring to? I'm referring to the latus rectum. Latus rectum is a line segment that connects your parabola through the focus. Okay, so if the entire latus rectum is 8 units, that means I have to go 4 units on either side of my focus. So 1, 2, 3, 4. 1, 2, 3, 4. And then this is what my This is how wide my parabola is. I know that my parabola goes, whoops, like this. That's not the best drawing of a parabola, but I think you guys get the general idea. It should be more curved. Okay, so this right here, this line segment right here is 8 units. That is called your latus rectum. This sounds like a biology class. Latus rectum, and it's 4p. The length of that line segment is 4p, and that tells you how wide your parabola is. So your latus rectum is 4p. It sounds like I'm saying something not very nice, but the latus rectum is 4p. The length of it is 4p, and that's how you can figure out how large your, or how wide your parabola is. Okay, let's look at the second problem here. What we need to do is to go ahead and complete the square. So I'm going to pause the video and do that. Why don't you pause the video and do that as well? Okay, so here is when you complete the square. Because you're only completing the square on one of your variables, because only y is squared, you want to keep the y squared and the 2y on one side of your equation, and you're going to move the 12x and the negative 23 over to the other side. Okay, so I'm going to complete the square on y, and so I'm going to take half of 2, which is 1, and square that, which is 1. Make sure you add that to both sides. When you rewrite the left-hand side, you get y plus 1 squared, and then over on the right you have negative 12x plus 24. So what we're doing is we're putting this into standard form of a parabola. You'll see here that on the right I can factor out a negative 12, and now this is the form that we want. So from this I can figure out my vertex, I can figure out my focus, I can figure out my directrix. My vertex is at 2, negative 1. And now 4p is going to be negative 12. You see that what is outside the parentheses there is negative 12. Okay, so I have 4p is negative 12, so p comes out to be negative 3. And now that I know what p is, I can find my focus and my directrix. Remember that because it opens to the left, I have to do everything off of my x-coordinate. So I get my focus is at negative 1, and my directrix is at x equals 5. It might be easier to graph these if that helps you, to just plot it out on graph paper. Sometimes visually that makes it a little bit easier. Okay. The axis of symmetry is the x-axis and passes through the point 4, 6. How are we going to do that? If the axis of symmetry is the x-axis, that means the axis of symmetry is horizontal. If it's horizontal, that means I have a parabola that opens to the left or to the right. Okay, if my parabola passes through the point 4, 6, so my point 4, 6 is somewhere up here. So I know my parabola passes through that point. Okay, I have to figure out what the equation is. So all I'm going to do is substitute 4 in for x and substitute 6 in for y to figure out what p is. So I have 6 squared is equal to 4p times 4, and that gives me 36 is equal to 4p times 4. Now a lot of people here will solve for p, but here's the beauty of this. I'm not asking you for what p is, I'm just asking you for the equation of the parabola. Okay, I'm just asking for the equation of the parabola, and I didn't say that up there, but that's all I'm looking for. And I need 4p to find the equation of the parabola. So in this case, 4p is 9. And I know that the parabola then is y squared is equal to 9x. Okay, I'm going to finish the last two problems up in the next video.